All right, the cast rule. So this is something that you guys are going to want to memorize. Maybe write down up in the top corner of a test if you have a test. So the cast rule tells us where each of the primary trigonometric ratios are positive or negative. It's going to come in, or it's going to become important here in a minute. If a trigonometric ratio is not listed in a quadrant, it is negative in that quadrant. So what that means is that, so remember what the trigonometric ratios were? That was that, I'll even write SOHCAHTOA up here. Okay, so those are our trigonometric ratios, right? So what that means is if I've got a line going, let's say, straight out here, anywhere in this quadrant, then, and I kind of make my, how should I do this? Yeah, make a triangle like that. Okay, so if I make a triangle like that coming out, right? Sine, if I go opposite, in this case, the opposite side is going straight up. So the opposite side here is going to be positive, right? That end up being a positive number. Whether that was 1 or 2 or whatever it was, it's going to be a positive number because it's going up, right? It's going up the y-axis. So this is going to be positive. The hypotenuse, really important here, the hypotenuse is always positive. So this arm that's going to be swinging around all these different directions that we're going to be going here, it's always positive. The only thing that's going to ever be negative or positive is going to be the opposite or the adjacent side. So the x value or the y value. You can think about it that way too. But in this case we have right now, we've got this value here for sine, let's say, opposite, is going to be positive. Hypotenuse is positive. So no matter what numbers I put in here, the value of sine whatever is going to be positive. So let's actually just put some numbers in there maybe. So let's say we had a point here, like, I don't know, 0.2 comma 1. Well, actually, let's make it a little easier. Let's call it 0.1 comma 1, just because I know what if you did a squared plus b squared is equal to c squared, this would be 1, 1, and this would be square root 2 in the end. 1 squared plus 2 squared is equal to, 2 squared. Okay, so that ends up being square root 2. So if you do that, and I want to figure out the sine ratio there, that would be sine opposite, I'm going to call 1. My hypotenuse would be root 2. And it's going to be positive, right? So no matter what I have here, it should be theta 2. This is going to be positive. I can't say the same, let's say, for sine if I was down here. And I had, 0.1, negative 1. So this is 1 and this is negative 1 coming down, right? Now, for sine, I'd have sine theta is equal to, should that equal sign there too, is equal to negative 1 over square root 2. So you can see that my trig identity for sine is now negative down here, but it was positive up there. It would also be positive over here. Sine would also be positive, because I'm going to have 1 coming up here, so this would be like, positive 1. And this will still be, root 2. So now I have sine theta is equal to, well, again, it's going to be 1 over square root 2. So again, it's positive. Down here, if I did it again, I'd have now negative, right? This would be negative 1 coming down. So it's going to be sine theta is equal to negative 1 over square root 2. So you can see that we've got pretty much the exact same thing, except in all and in sine is going to be positive. Down on the bottom, it's going to be negative. So they're all going to be kind of different, right? So I'm just going to clean that up a bit. Oh, shouldn't erase that. Okay, so it's going to be a little bit different for each one though too, right? Because you can see now, let's make another triangle like this again, and again I'll say, this is negative 1, so 1 down, and it's going to be negative 1 on this side, right? It's just going left and it's going down. This is still going to be square root 2. But let's say I want to find the cos identity of that. So cosine theta is equal to, adjacent over hypotenuse, so adjacent -1 over square root 2. So negative again, right? But cosine would be positive over here, and it would be positive over here. So that's pretty much it. Maybe it'll definitely kind of maybe help if we kind of go through some more. So I'll go down. All right. So it says each angle is in standard position. State the quadrants in which the terminal arm of the angle could lie. There's going to be two options, right? Because for every one of them, let's say for cosine, it could be positive here, and it could be positive there. They're all positive there, right? That's what all means. Okay, so there's going to be two answers for each of these. So the first one, we've got sine 4 over 5. Okay, so sine, remember, was, so if we go SOHCAHTOA, sine was opposite over hypotenuse. Let's do this. So opposite over hypotenuse, so it's saying 4 is my opposite, 5 is my hypotenuse, and it's positive, right? The thing that I'm looking for here is that there's no negative sign in front of that, it's positive. So a couple ways that you could think about this. First off, I can say, well, sine's positive, so it must be in either quadrant 2 or quadrant 1, because that's what my little cast rule says. So it's going to be 2 and 1. The other way of thinking about it is actually thinking about what's happening. So you've got your opposite is going to be positive. So if I drew a triangle, that means my opposite side is going to be above the x-axis here. Whoop. And it would also be above the x-axis here, right? Both those situations. So quadrant 1 and quadrant 2. So that's kind of what's actually happening there. If it was negative, then it would be below the line, right? And it'd be like down here. Okay, so let's look at this one. Cosine -1 over 2. So cosine was adjacent over hypotenuse. So I'm going to think about it and say, okay, well, adjacent is -1. So that's going to be, so if this was, so if it was like this or like this, it would end up being negative, right? So the x value, my adjacent angle, or side, sorry, is on the negative part of the x-axis. So it would be there and it'd be there. You could also look up at your little chart and say, okay, cosine is positive in this one and positive in this one. So that means it's negative over here and negative over here. So in 2 and 3. Okay, tan 1 over 5. Well, I know it's going to be in this one, right? Because we already knew from our cast rule that all of them are in that one. They're all positive in that one, right? It's positive. That's what's important there. But the other one I'm going to be able to figure out is that it's also going to be positive over here. Because if you think about it, I'm going to have a negative going this way, but then also a negative going down. So I've got a negative over a negative. So that would also give me a positive ratio. Because if you actually did this, it'd be -1 over -5 on this side, right? -1, -5. But -1 divided by -5, that's positive 1 over 5, right? The negatives just kind of cancel. But then the other way you can think about it is your little table tells you that tan, when it's positive, it's down there. And just to save time, this one's negative, so I'm just going to look up my chart. Well, it's going to be negative in 3 and 4, right? The two bottom ones is where sine is negative. Whoop. So it's going to be negative down there. So 3 and 4. Well, I forgot to put that one. This was 1 and 3. All right, this one says the point B is at 2, -5. Is on the terminal arm of an angle theta in standard position. So what it's saying is it wants this angle. It says sketch the angle. So what we got to do first is figure out what this angle actually is. So there's two ways of thinking about the angle. There's the angle theta, or the one that's going right, like the rotation angle, or there's the reference angle alpha coming from this side. It's going to be easiest if we draw a triangle. Well, I know first off that this side of the triangle is going to be 2, and this side's going to be -5. And that's good enough for the sketch for part A. Part B says determine the distance from the origin to point B. Well, that's going to be pretty straightforward. That's just a squared plus b squared is equal to c squared. So if you do that, you get c is equal to square root of 29. So this is square root of 29 on that side. What's the name of this line? That's the terminal arm. So just like in the last video. So now write the primary trigonometric ratios. I'm just going to pause that and do it. Okay, so just using SOHCAHTOA, you can figure out the trig identities right there. Now determine the measure of theta to the nearest degree. Okay, so I just put the numbers in here. So it says -68, 68 here, and then -68 there. Before I was showing you that it didn't matter what you did here. You ended up getting the same degree, right? But what we're kind of stumbling across here is that if you've got your Cartesian plane, and we were looking at this one, right? So if we go back up to the beginning, well, we know that the angle was down in quadrant 4, and we were looking for our reference angle right there. It's going to be the first one we want, right? But if I look at, so sine this part right here, so sine theta is equal to -5 over square root 29. Well, according to my cast rule, sine was negative in this one and in this one. So it was saying, sorry, I lied to your face. Sine was negative in this one and this one, right? It was positive in the tops. So it was negative into that one. So what it's giving us, when it says -68, the negative, all that means is that you're going, instead of counterclockwise like you normally do, you're going clockwise. The negative just means you like rotate the opposite way. So this is 68 degrees, which is the angle that we want, right? That is our reference angle. So the negative there just tells us what direction it was rotating. If you think about this one, the next one over here, I'll make that in blue maybe, and look at cast. If I look up here, it was positive 2 over square root 29, so positive though. So it knew that it was either there or there. The calculator gave us positive 68 because it said, well, that one. It knows that there's two answers, but it just kind of picks the closest one. So it chose this and said, well, that's 68 degrees. Crap, I'm really messing up with my, I'm testing you. It wasn't there, it was there, and it was there where it was positive. So it just chose this one because it was positive. It could have just easily said down though too, right? Because it knows that that's positive in both those cases. So that's 68 degrees and that's 68 degrees. If I look at the next one here, just to see what it did, why I got that negative answer. If I look at my cast rule again, tan, it was -5 over 2. So negative, when tan is negative, it's going to be here and it's going to be here. So what it did again was it went from here and just went down -68 degrees. So that's all it did. It doesn't really matter though. What's usually going to pop out is it's going to pop out our reference angle at us, usually. I'll show you in the next one though that might not be the case. Okay, I'm going to get you guys to go ahead and do this one on your own. So it says the point B, -2, -4 is on the terminal arm of an angle theta in standard position. Sketch the angle. Determine the distance from the origin to B. So the same as the last one, right? So go ahead and give that a try, and then I'll pop up the answer at you here in a minute. Okay, so like I said, the angles here came out a little bit different this time. So what I want to show you is kind of what they all mean. So the first one, when I found sine theta, I had -4 over square root 20 up here. So sine was negative, right? So that's what I was saying. So if I look at my cast rule down here, sine is negative down there and down there, right? So what this negative 63 is telling me is it's just telling me that this is negative 63. But what I can say, though, is that then this is also 63. So I'm just able to kind of intuitively see that, right? That they're both those reference angles are the same there. So that's all that one's telling me. So pretty much I know my reference angle is 63 degrees. But what I wanted to kind of draw your attention to is this 117 degrees. So what this is one of the rare situations where it won't give you your reference angle. And that's because if I look up here and say, okay, where is cosine negative? Because it's negative 2 over square root 26. Well, according to my cast rule, cosine is going to be negative over here, there and there, right? So the closest angle that your calculator was able to tell you was this angle. It says that this is 117 degrees from there to there. So easy jump to figure out what this angle or this angle would be, which are our a reference angle, right? Alpha symbol there. Is you just need to go 180 degrees minus 117 degrees, which is 63 degrees. So it's the same thing, right? Reference angle still ends up being 63 degrees, that point and that point. And then this one, so where is tangent positive? So according to my cast rule, it's positive here and there. So it had there and it had there. And it told me that it's 63 degrees. So what it really told me was this angle, right? It went up positive 63 degrees from there to there. But I know that that's the exact same thing as this because they're the same reference angle, right? So this is 63 degrees. So in the end, all ended up being 63 degrees. All right, last example. Says given that cosine theta is equal to negative 3 over 4, determine the other primary trigonometric ratios of the angle theta. Let's cross that one off. Let's just do this and then figure out the degree. Okay, so what I want to do first, let's just sketch it. So I'm going to just do a rough sketch. Negative 3 over 4. Well, cosine, remember. You can remember this way too. Cast. Cosine is going to be negative over here and over here. So I'm going to have one drawing where it's over there. And I'm going to have another sketch where it's down here. And it's really... So Katoa. So cosine, the top one's adjacent. That's the only one that can be negative or positive, right? The hypotenuse is always positive. So here it's the 3 that's negative. So it's going to be 3 over here. So on this triangle, this is going to be negative 3. And my hypotenuse is going to be 4. On this triangle, this would be negative 3, and my hypotenuse would be 4. Okay, and what we're looking for on both of these, actually I'll just, if you did your Pythagorean theorem, this would end up being square root of 7, I think. Yep, square root of 7. And then this one would end up being square root of 7 as well. But one thing you got to check and make sure that you do, because it's a common place to make a mistake, it's negative square root of 7 because it's going down. You just kind of have to add that after the fact. Okay, just make sure you remember that. Okay, so that's negative square root over 7, or negative square root of 7. Now what it's looking for are the angles. So I'm just going to draw in, there's my alpha angle there, alpha, or my reference angle, and then a rotation angle, theta, on both, theta. Okay. So if we want to figure out the degree here, we just have to actually set it up. So cosine, I'm just going to write cosine, the original ratio was this, negative 3 over 4. So if I want theta, I'm going to go theta is equal to cos negative 1, negative 3 over 4, which is equal to 139 degrees. Well, there's two numbers that could be. It could be this top one, or it could be this one. I know it's the top one because it's less than 180 degrees, right? 139 is less than 180, so it's really talking about this angle right there, right? So we figured out one possible value. We figured out the one up here, so that's good. We got to figure out this one. What's the possible angle here? So all we have to do now is just figure out what our reference angle is. Figure out what alpha is there. Well, I can figure that out pretty easily just by going 180 minus 139. I should put degrees on both of those. Which is equal to 41 degrees. And the reason I did that is because now I can see, well, that means this is 41 degrees. But that also means that this is 41 degrees, right? So if I know that that's 41 degrees, now all I have to do is go 180 plus that reference angle of 41 degrees which is equal to 221 degrees. So those are my two possible angles. Sorry about the long video. I'm going to end that one there.